So thank you very much for joining today's session, which is focused on extended network visibility with Flowmon Probes. My name is Luboš Lunter. I'm a product manager at Flowmon Networks based in Czech Republic, Brno. I prepared today the session with the introduction of Flowmon Probe, the capabilities, the comparison and motivation why to use Flowmon Probe, and in contrast to using flow from switches, routers, or firewalls and other devices. So we will show where the probe can bring some added value in flow exporting, and also some other nice features of Flowmon Probe. If you find some troubles with audio, video, please let me know via questions as well, so I will be informed if everything is going well. So let's go for just a few words to introduction of our company, Flowmon Networks. We are a vendor of network traffic and performance monitoring and security as well. We are currently, our customer base is more than 750 customers worldwide. Most of the customers are in Europe, Japan. We are opening branches around the world, USA, Philippines, Scandinavia, and other parts of the world. Actually, we were the very first vendor worldwide with 100G probes offering. So as you will see, the probes are our real piece of unique hardware, and equipped with unique software as well. We have very strong R&D background, as we were originally a university spin-off, and this cooperation with academia is transformed to very innovative technologies. We also partner with premium technology vendors, and we are recognized by Gartner in the primary in network performance monitoring and diagnostics Magic Quadrant, and some achievements. As you can see, the listing in Deloitte, Technology Fast 50, and other stuff. So this was the general top-level introduction of our company, and let's do the deep dive into Flowmon Probes and into technologies behind flow monitoring. So why we need network monitoring? Obviously, we need to have the visibility if we want to monitor and protect the networks, and that's why we use primary flow data. We collect flow data in Flowmon Collector, which is the central appliance, and you can see that collector can handle data from routers, switches, firewalls, and one of the options is Flowmon Probe. So when we are talking about flow export from routers, switches, and other appliances into network, they typically support NetFlow 5 or NetFlow 9, sometimes IPFIX. The collector can store flow data in various formats. It can even combine flow formats from these sources. So it can store some data in NetFlow, some in IPFIX, JFlow, and other formats. And what we are talking today mostly about is Flowmon Probe, and I will show you in following slides where is the added value of Flowmon Probes, what is the performance, which layer 7 visibility it can bring, what are the deployment scenarios where is typically Flowmon Probe deployed in the network, and compare to these scenarios, so you will be able to understand if in your case you will be connecting probe via tap or a span port, or if you need layer 7 visibility and on-demand full packet capture, which is for which is mandatory to have Flowmon Probe in place. And just to end and finish this architecture, over the collector we run software applications of modules for the network visibility and network performance monitoring and diagnostics use cases. Then the network security, we call it network behavior analysis. We run machine learning mechanisms over the flow data stored in the collector to reveal threats and malicious behavior in the network. Then we use Flowmon Probes to do network-based application performance monitoring as well. And as I've mentioned, we can do also the full packet capture, on-demand full packet capture using Flowmon Probes. So you can store PCAP, not because of course IPFIX and NetFlow is metadata about the communication. There is no payload in it, and if there is needed to have more detail for these reasons, there is extension module in form of a Flowmon traffic recorder, which performs the on-demand full packet capture. And the very last use case is using the flow data for volumetric DDoS attack detection and mitigation orchestration. So this was regarding the top-level architecture, and now let's move into the Flowmon Probe and what challenges we have when doing network monitoring and when gaining the visibility in the network. Of course, the full packet capture solutions are very resource consuming, and also the work and workflow when analyzing full packet captures in Wireshark is very time consuming and also skills requiring. So we provide some feasible alternative in form of flow data, which has quite fair amount of data about the communication. And if there is if the flow data is exported from active devices, sometimes it is not accurate, because of course routers and switches, their primary role is to do routing and switching, not to do the flow exporting primarily. So if there is high load in the network, the first feature which is being stopped is flow export. So once you need high performance and accurate flow data, it's always good to consider a standalone probe, which is dedicated flow data exporter. And the top advantage of the probe is that it does kind of deep packet inspection, so it can enrich the traditional layer 3, layer 4 flow information with application protocol visibility and also extensions and layer 3, layer 4 with network performance metrics. So I will show you the details later. So these are the challenges and how to deal with the challenges. So let's see, once we put Flowmon Probe in the network, what we can get from the probe. Of course, the performance is the top driver for deploying probe, which can Flowmon Probe can export flow records in NetFlow 5, 9, and IPFIX as well. It is invisible on layer 2, layer 3, so it's transparent for a monitored network. Typically, it is one new appliance or one new hardware appliance or virtual appliance. yeah, it is managed by a graphic user interface, and it's very simple to configure the probe. As there is no almost no skills needed. It's very easy to just to configure the monitoring ports, and you choose what extensions would you like to export, and then the probe exports the statistics to your collector. So how it works, monitoring ports convert packets to flows. Typically, it's unsampled flow. Of course, we provide the option for sampling if needed. Then the top performance of probe appliances is 100G wire speed. They provide layer 2 up to layer 7 visibility, and can provide PCAPs if needed. That means that real full packet capture is stored, which is managed by Flowmon Traffic Recorder module. So let's take a look on what visibility and in what protocols where can help Flowmon Probe, which protocols can enrich the traditional layer 3 and layer 4 items. So from layer 2, it is information about MAC, VLAN, MPLS, GRE tunneling, OTV. Then from layer 3, layer 4, the standard items, I mean standard NetFlow items, which is typically information such as source, destination, IP addresses, ports, protocol, timestamp, counters of bytes and packets. But on layer 3, layer 4, the probe is able to enrich the information with NPM metrics such as round trip time, server response time, TTL, SYN size, autonomous systems numbers, and others. And I will show you in following slides what exactly, where is exactly the benefit in form of visibility, and what IT operations guys, how can they use this extended data. And from layer 7, it is visibility into NBAR, application tags, HTTP, SNI, DNS, DHCP, and other protocols. So let's start with network performance monitoring and with NPM metrics, which are measured by Flowmon Probe. So they deliver server response time information, round trip time, and delay, jitter, and TCP retransmissions. Let's take a look at how it appears in the charts, visualizations, and analysis. So in the profiles traffic, we can draw the line, not only the flows, but also the black line is server response time. So the operator can just click on the peak in server response time and investigate why it was what was the cause of this peak, and it is displayed in time. So very easy for fast investigation. But what is the principle, how it works? Here we can see that we have client, probe, and server. And let's take a look how the probe is measuring the NPM statistics. So when we have TCP handshake, there is a SYN. After the SYN, there is a SYN-ACK, and after the SYN-ACK follows ACK. And you can see that the probe can measure the time between the SYN and ACK, and which means round trip time, represents delay introduced by a network. So this is obviously for TCP traffic. We can measure RTT because we see into each part of the communication, and the probe can store this data together with other IPFIX items. Then we have client request. So first there is a request. After the request there is ACK, and then the data is sent from the server to client who has requested them. And again, we can measure the time between the ACK and the first packet of data. So then we see the server response time, which means delay introduced by server or application. And then we have server response when data is being sent from server to client. And then we can again measure the time between packets, and we see the delay, which means the delays between packets. And of course, once we have these delays, we can see also their distribution or variance, which means jitter. So this is how the probe can use the visibility into the traffic to bring this network performance characteristics. Another nice feature of Flowmon Probe is application recognition. So then you can see, maybe I will choose a pen here. So yeah, okay, now. So then you can see the nbar2 tag in statistics, which can be used also for filtering, reporting, and other work in the system. So thanks to this visibility, you can use application tagging when doing analysis. Okay, I need to. Okay, sorry, I had to switch off the pointer to be able to move in the presentation. So another information which can enrich the flow is autonomous system information. So it can be based on default or custom IS numbers list stored in the system. Then there is optional sampling on packet as well as flow level. So the probe can sample if needed. But what is more important than that, one probe can export NetFlow or IPFIX records to several destinations, and even in different formats. So here you can see the scenario where the probe sends or exports IPFIX to Flowmon collector. Then the same flow data is converted to NetFlow 9 and sent to CM system, which supports only a NetFlow 9, for example, and it again converts this data also to a NetFlow 5 and exports to some legacy system. So you can choose several destinations for flow data, or another option is to use the forwarding from one collector to another collector, because this is one of the option of collector, that it can forward the flow data to another source. And what is more more important that probes as well as collectors, when forwarding, supports encrypted and reliable flow exporting. That means that instead of UDP, there is a TCP connection, which can be optionally encrypted. So this is the way how to get flow data from branches to cloud or data center securely using the encryption and TCP connection. Here you can see some pictures from the configuration where you can configure the flow export, and you can also enable encryption here. Okay. When we are talking about hardware appliance, it is commonly used if the performance is needed, as top model of hardware appliances support 100G networks, and they work in wire speeds. We use hardware accelerated network interfaces where the data is processed directly on the network interface, so we can then handle that amount of traffic. And each hardware probe is equipped with a built-in collector, so it can you can put one probe with built-in collector with of course limited capacity, but still you can have one appliance, and you can do also the analysis. So it is like a comprehensive appliance which can do not only the export, but it is equipped with built-in collector, and you can do the analysis as well. When talking about the probes, there are several options how to connect the probe. The first is to have a probe on a span port or mirror port of a switch or router. Another is to put probe on a tab, and another option, special option, is in virtual environment, where you need to get traffic to monitoring port of probe and in virtual environment. Of course, all of these approaches or options have pros and cons. So when doing probing on a span port, there is you may reach capacity limit because of course if there is high traffic on the switch, it's you can, or the span port cannot gain the full performance and cannot mirror all the traffic from all the traffic going through the switch. In that cases, it's better to use a tab, which can be copper or metallic or fiber, and it basically mirrors the traffic. But of course, you need to put additional hardware into your network, which is the cons of this approach. What is the fact when you are considering the tab option and putting the probe on a tab or connecting probe via tab? You need to consider that, or you need to be aware that you need to have 2 monitoring ports for one line. So you need to choose appropriate probe model with sufficient amount of monitoring ports. Maybe some I will share some news that we are releasing also the AWS deployment of Flowmon collector, which is equipped with 2 monitoring ports, some inbuilt capability of Flowmon Probe. So if you want to have your AWS appliance, you can put Flowmon AWS, Flowmon AMI image into AWS environment, and you can easily create your virtual or cloud appliance in AWS. And in this year's roadmap, we have also the Microsoft Azure deployment, so it will be available also this year. And now let's have a look on IPFIX extensions. As I've mentioned at the beginning, one of the top features of Flowmon Probe is doing the extended visibility and layer 7 visibility. So we then can see to layer 7 protocols such as HTTP protocol. So operational guys can do the overview of most visited domains. They can the probe can do the passive device fingerprinting. For security reasons or for security use cases, we can use the HTTP information to check the access to unwanted or blacklisted domains and malware detection. You can see that we can work with HTTP informations and widgets, reporting, but all this data is stored in collector, so it can be used also for the filtering, and you can always work with the data such as HTTP hostname, HTTP URL, and use it for the investigation, or you can do the reports of most visited host names or so on. When talking about passive device fingerprinting, which is based on extended HTTP visibility, we can then get and store information about user agent, about the system of MAC address, IP address, VLAN tags, flow source, and other information, and store it together with NetFlow, and again use it when displaying the statistics. So you can then see what was the HTTP host operation system, what was the version of the operation system, build, HTTP host application, which means the browser, and other informations, very useful when doing the troubleshooting. And yeah, and important is that you probably know that the flow data is typically stored for months of history without aggregation. So IT operation guys and even security guys have these data stored for months, and they can do the investigation also after time without aggregation. So not only top statistics are stored, but for each communication they can find this information always when needed. Another layer 7 protocol is DNS and the visibility into DNS, which can be used, so log of DNS server transactions. From the security perspective, the Flowmon ADS can then check the translating malicious domains and the usage of unauthorized DNS server, and the operational guys can do the troubleshooting of domain translation and do the statistics, question types, response data, and so on. So let's take a look how it works. We have DNS query, a record type, and then we have a response in form of not existing domain. And let's take a look how it looks like in flow data. So we can see this query question type, IPv4 it's A, IPv6 is AAAA, and it can be the administrators can see all this layer 3, layer 4 information, which is the standard flow data, and together with it is enriched with layer 7 visibility, so real deep visibility into DNS protocol. Here you can see a screenshot from Flowmon ADS, how ADS can detect the communication with blacklisted host even from the DNS query. So even before the communication was established, just from the DNS communication, it can detect such communication. So you can then imagine some use cases, and after such an event, you can run a script reporting back to firewall to block this communication. And there is a lot of use cases to work here, as it's quite powerful tool, once allowing the script triggering, and also RESTful API is available here. Another layer 7 protocol, voice over IP. So we can see the information from SIP, RTP, RTCP protocols, which is from the operational perspective for troubleshooting and analysis. Then for audit and to have complete calls list and detailed information, detection of some premium number calls, and of course the security is also important, where VoIP attacks detection like SIP floods scans can be detected by Flowmon ADS, or detection of SIP proxy servers. Yeah, here is just detail regarding the VoIP, so you can then see all the information about the calling party, called party, call duration, ringing time, answer time, and other information stored in the VoIP protocol, which can be then used for the investigation and quality of VoIP service insurance. So also very powerful tools for operators dealing with the VoIP traffic. Another protocol from the family of layer 7 protocols is SMB. It's commonly known as Samba, file sharing protocol in a Microsoft environment. It's again wide to analyze SMB on application layer. You can see who accessed specific files. It's not dependent on platform or application or user, just from the network data. You can see all you need there for the investigation. From the security reasons, you can see what files were created. From the operational perspective, you can do the troubleshooting, or you can check who accessed to the network resources, and also doing the general usage monitoring of shared resources. From the security perspective, you can also use this visibility to detect ransomware activities. Maybe you can remember the Loki case. Here is a very simple alert on Loki presence. When you create alert with the suffix of .loki, and thanks to the visibility into SMB, the system reports right after some file with this format appears in the network traffic. So it filters on such an extension, and if there is any occurrence, it immediately triggers the alert. And here you can see the analysis of SMB protocol. So first, there is some infected host which makes a local copy of file from shared storage. You can see it from the SMB2 command. Then you can see in number 2 that there is evidence about the deleting file from shared storage, and the last part of the picture is showing that encrypted file is uploaded back to shared storage. So then again, the network data provides evidence about the infection in the network and about encrypting the data. So you can again use it for alerts, and you can check where in your network this happened. There are several types of SMB protocols used. The SMB1, we provide the visibility in the operation type. As in SMB2 version, we provide the full visibility, and unfortunately SMB3 version is encrypted, so it is not supported because the layer 7 monitoring on encrypted traffic doesn't make much sense as it is encrypted, and there is no option how to get these data from the network traffic. So here you can see what statistics are available in SMB and how it can be useful for the reporting and to being aware what's going, what is the SMB 3 path. You can directly see in the statistics this SMB value here. And now we are going to the finish of the webinar session, just DHCP protocol analysis. Again, you can have full log of DHCP allocated IP addresses. Then you can use this data in Flowmon ADS for the security to detect unauthorized DHCP servers, spoofed addresses, and network configuration. And from the operational perspective, you can always do the troubleshooting and analysis of DHCP server as you have the real visibility into DHCP communication. So here on the first picture, you can see the traditional flow data. That means the IP is source IP address, port, destination IP address, destination port, and on the right side you can see what was the DHCP host MAC, what is the host name, DHCP server request, and other DHCP statistics. And then you can see that you can set a profile for DHCP traffic to be able to have widgets displaying the DHCP traffic on your dashboard, and you can create alerts on DHCP communication as well. So you can be alerted once there is some communication with which was unexpected or which is of interest of you. So it's again very flexible alerting here. And finally, just to remind, we went through most of, we went through all important features and benefits of Flowmon Probe, including the layer 7 visibility and its performance. The second very interesting feature was the secure export, encrypted export via TCP connection. Third was the on-demand full packet capture, which can be done via Flowmon Probe and provide the PCAP with the real payload of the communication. And this on-demand full packet capture is integrated with Flowmon ADS, the security module. So once the security incident is detected, it can automatically trigger the on-demand full packet capture, and then the PCAP is stored together with flow data. And of course, the 100G networks, which can be monitored or where can be placed hardware model of Flowmon probes, or in virtual networks, 10G probes. And then we went through IPFIX extensions. That means that layer 7 visibility and using these layer 7 data in the filtering, reporting, and when doing the analysis and displaying this information to be able to help IT operation guys and security guys to deal with their common problems and troubleshooting and everyday's work. So this was all from today's session. I will wait for your questions, so feel free to use questions app. We can discuss your questions. Yeah, there is a question regarding the number of monitoring ports of Flowmon Probe. We have modules with different numbers of monitoring ports. You can find the specification of Flowmon Probes in resource library in Flowmon Web, where there is complete text specification, so you can have, for example, 2 monitoring ports, 4 monitoring ports, 8 monitoring ports. Depends on the needs, but again, just you need to be aware once connecting probe via tab, you always need 2 monitoring ports for monitoring of 1 line. So if you need to monitor two lines via tab, you need to go for the module with 4 monitoring ports. So this is how it works, and the detailed specification is available publicly in resource library of at our website. Okay, so if any other questions, if you have some questions later, feel free to contact me directly, or you can use our social media. You can use our chat at Flowmon website. We can always discuss your very specific questions. Thank you very much for your attendance today. Pleasure. It was a pleasure for me to spend this session with you. And another webinar session will be focused on the DDoS capabilities and use in Flowmon's DDoS Defender. So stay tuned for Flowmon webinars, and I'm looking forward to seeing you again. Thank you very much and goodbye.